Hi everyone, so kita nak start dengan beberapa soalan, nak bincang beberapa soalan yang melibatkan konsep untuk chapter 3 iaitu momentum and impulse. Alright, are you ready? Let's go. Which takes more force to catch, a bowling ball or a ping pong ball? So dalam kes ni kita akan gunakan J equals to F delta T dan J juga ialah M V tolak U. So daripada sini kita akan dapati F delta T sama dengan M delta V. Daripada sini kita dapati bahawa force berkadar terus kepada mass. Dan kita boleh katakan mass untuk bowling lebih besar daripada mass untuk ping pong. So kita boleh katakan force untuk bowling lebih besar daripada force untuk ping pong. So which takes more force to catch, bowling ball or a ping pong ball? Is it a ping pong ball? No. Bowling ball because it has more momentum, or bowling ball because it has less momentum? So the answer is bowling ball because it has more momentum. Next, suppose a ping pong ball and a bowling ball are rolling towards you. Both have the same momentum and you exert the same force to stop each. How do the distance needed to stop them compare? Diberi bahawa So diberi bahawa momentum untuk ping pong ball ialah sama dengan momentum untuk bowling ball. Alright. So kita tahu mass ping pong, velocity ping pong sama dengan mass bowling, velocity bowling. Okay. Since mass of the bowling is bigger than mass of the ping pong, maka velocity of the bowling smaller than velocity of ping pong. Dan kita juga tahu bahawa velocity berkadar sama dengan displacement over time. Daripada sini kita dapati bahawa velocity berkadar terus kepada displacement. Since velocity of bowling is smaller than velocity of ping pong, hence the displacement of bowling is much less than the displacement of ping pong. So, it takes a shorter distance for the ping pong ball to stop. The distance to stop are the same. It takes a longer distance to stop a ping pong ball. Yes. How can a tennis ball and a bowling ball have the same momentum? And based on P equals to mv, mass of bowling and a tennis ball are totally different. So in order to compensate the same momentum, we must have different speed. If a large train, F train, collides with a car, F car, which of the following statement is true? Check all that applies. So untuk setiap force requires two bodies to act. So untuk saya gerakkan tangan saya perlukan mass of my hand and another hand to push. So it requires two bodies to act. So in other words, we can say that force of the train is equal to force of the car. And then another thing is force of the train must be in opposite direction of the car. This one applies the Newton's third law of motion. Every action has an equal and opposite reaction. So in this case, the answer is this one and this one. Two objects P and Q have the same momentum. Q can have more kinetic energy than P if it has. So we go to the kinetic energies equation. K equals to half mv squared. And we can see here that the kinetic energy is directly proportional to the velocity squared. So in order for the Q to have more kinetic energy than P, means that the velocity of Q must be more than the velocity of P. So you can choose more speed than P. In any collision, the is always constant. So in any collision, the total momentum is always constant based on principle of conservation of linear momentum. Card A is pulled with a 2 Newton force for 2 seconds, and card B is pulled with a 1 Newton force for 3 seconds. Which card experiences the greatest impulse? So we go to J equals to F delta T. So J card A equals to F, which is 2 times for 2 seconds, equals to 4 Newton meter. And for JB equals to F, sorry, this is not Newton meter, this is Newton second. Newton second. And for JB, which is impulse B, F equals to 1 and time is 3. So the answer is 3 Newton second. So which card experiences the greatest impulse? It is card A. Softer landings tend to increase collision time, increase force, increase change in momentum, increase impact force. So the answer is increase collision time. The law of conservation of momentum states that P before is less than P after, P before is more than P after, P before is the same as P after. So summation of P initial equals to summation of P final is the correct answer. So we're going to choose this one. Consider two carts of masses M and 2M at rest on an air track. If you push each car for 3 seconds, exerting equal force on each, the momentum of the light car of the push is than the heavier car. So we go back to J equals to F delta T. We can see that the force untuk M is equals to F for 2M's. And then the time T for M is also equals to delta T for 2M's. You can see that the momentum, change in momentum, is exactly the same. J for M is equals to J for 2M. So they are exactly the same. Next we have here, when the speed of an object is doubled, its momentum. So we go to P equals to mv, where the new velocity is doubled the original velocity. So what happened to the new momentum? We have to use this. And from here, we can see that 2mv. P equals to mv is this one. So we can say that the new momentum is 2 times the original momentum. It is doubled. Check all that apply. Impulse is a vector? Yes. A change in momentum? Yes. Not a vector? No. The change in velocity that can be caused by a constant force over some discrete amount of time, which is J equals to F delta T. Yes, the force that creates an acceleration. Now this is a different story. In an isolated system, the net watt on that system is 0. So in an isolated system, basically we are talking about isolated system, no external force. So in this case, the system has 0 external force. The difference between a car hitting a wall versus a car hitting a haystack is the impulse on the car hitting the wall is greater, the collision time of the car hitting the haystack is greater. I think this is it. I think this is the correct one. T is bigger. The change in momentum of the car hitting the wall is greater. No. The force on hitting the car of the haystack is bigger. No. So we go for this one. The difference between the car hitting a wall and the car hitting a haystack is time. Linear momentum is defined as a product of a system multiplied by its So P equals to mv, so mass and velocity. Consider two carts of masses m and 3m at rest on an air track. If you push a cart for 2 seconds, exerting equal force on each, the energy of the light car after the push is this one. So let's go to m1 equals to m, and for m2 equals to 3m's. So what is the energy of the light car, which is E1? So let's go to the equation for energy. So in this case, we have half mv squared. This is our equation that we want to go. So let's go to E1 first. E1 has half mv squared, which is E itself. For the E2, it is equal to half 3m v squared. We factorize everything, which is equal to 3 times half mv squared. And we can see from here, it is actually 3 times the original energy. So when we want to compare with its exerting equal force, we're going to see like this. F1 is equal to F2. And then we know that, I'm going to put it here, force equals to energy over time. Displacement. So E1 over displacement equals to E2 over displacement. And then from here, we can see that you can cancel out this one. The E1 is equals to the E2, which is 3E. Okay, so the light car after the push is 3 times greater than the heavier car. What is Newton's second law of motion? So Newton's second law of motion is F equals to ma. An object acted on by an unbalanced force with accelerated in the direction of that force in direct proportion to the strength of the force and inverse proportion to the mass of the object. A car of mass m traveling at speed v stops in the time t when maximum braking force is applied. Using the same force, F1 equals to F2, what time would be required to stop a car of mass 2m traveling at speed v? So we go back to J equals to F delta t. from here, we know that mass is G equals mass times final velocity minus initial velocity. This is, we're going to copy it back. Then I'm going to change the delta t as the subject, m delta v, because v minus u is delta v. This is where the force, I'm going to put the force. So what happened to the new speed? So delta t, the new delta t, equals to m prime, the new mass, the f delta t, sorry, f. So here we can see that the new mass is 2m, delta v over f. To compare it with this one, you can see this is this. Hence, we can say that the new delta t is 2 times the original delta t. Can a bullet have the same momentum as the truck, as a truck? Absolutely yes. P bullet can equals to P truck. By changing the distance, the velocity as truck of the bullet and the truck. So the answer is yes. Objects on Mars weigh approximately 38% more than they do on Earth. Will a 10 kilograms bowling ball moving at 5 meters per second have more momentum on Earth or Mars? We know that P equals to mv. Hence, we can see that weight has no factor whatsoever to the momentum. So we can say that momentum is the same for both planets. The unit for impulse are kilogram meter per second and Newton second. And the last one, the unit for impulse are Newton second. So that's all from me. I hope you will do your best in your UPS 1. Good luck. Bye.